So what you've seen so far is how to visualize rational numbers on the number lines and also as parts of whole. Remember, our definition of a rational number is a real number that can be represented by an ordered pair of integers a and b. The numerator is a, denominator is b. So this number that sits here is called numerator. This is called the denominator. And the denominator has to be non-zero. Remember how we said in order to consider mathematics as fun and to play, we can immediately now look at rational mathematical objects. So the word rational means you have to have a numerator and a denominator. If you replace numerator denominator by different objects, we end up with rational mathematical objects. For example, if you have the fraction -3/5, so here's a rational number where numerator and denominator are integers. What if I replace this 5 with an x? So this x is now a variable or an algebraic expression, and we say we now have created a rational expression or an algebraic expression or algebraic fraction. You can replace both numerator and denominator by algebraic expressions. Here are some other examples. You have polynomial over polynomial. So this is called a rational expression or algebraic expression. You can also replace the numerator denominator by other objects like functions, for example. And so even if you don't know what a function is, what do you think we're going to call this fraction where you have this function on top, the second function on bottom? Of course, we're going to call it a rational function or quotient of functions. So rational functions are simply functions where numerator is a function, denominator is a function. And if you know what functions are, then just remember that the denominator cannot be 0. So we will consider discussing functions more detail later, and we'll bring up rational functions then, but we thought you should at least have a sense of how the word rational is used. So rational function means you have a numerator, you have a denominator. If I say rational function, then the numerator and denominator is made up of functions. We're going to talk about visualizing equivalent fractions. So for example, remember 1/2 means 1 part out of 2. 2/4 will represent 2 parts out of 4. If you're talking about the same amount of whole, and if you're occupying the same amount of space in that whole, like 1/2 and 2/4, so you can say how this 1/2 is occupying equivalent space as 2/4 is in this whole. So 1/2 and 2/4 are equivalent fractions. This equivalent fractions, knowing when two fractions are equivalent is going to help you in lots of different problems. This next few slides are going to be perhaps a little bit harder to understand. So have patience, pause the video, rewind the video when necessary, and that will make sure you understand the material. So we already know how to visualize 1/3, 2/3. So here's my whole. So here's my whole, and here's 1/3 segments of this whole. 1/3, and then these two make 2/3, and so on. And the whole thing is 3/3. So now let's take a look at the same segments of 1/3, but see what happens if I take this one and divide it into 2 pieces. I have to do that across everywhere, because if I want to write it as a fraction, I want to divide the whole thing into equal pieces. So look what happened. Here was my 1 piece, but now that 1 is made up of 2 pieces. I have 1 group of 2. So this is the 1 group of 2. My original 1 is now 1 group of 2. My original 3 is now 3 groups of 2. Here's 1, here's 2, and here's 3. And so 1/3, right? 1/3, this is 1/3, is the same as 2 out of 6. Similarly, 2/3, where was 2/3? We have 2 groups of 2's out of 3 groups of 2's. Let's take a look at this example. Again, I have 1/3, and I'm breaking it up now, this 1/3 into groups, equal groups of 4. So one group of 4, second group of 4, third group of 4. So what do you think this is going to be represented as? I have one group of 4, so 1 times 4, one group of 4 out of 3 groups of 4, right? 1, 2, and 3. 3 groups of 4. So 1/3 is the same as 4/12, because one group of 4 is 4, 3 groups of 4 is 12. You can even count by hand, even if you don't know how to multiply. And so what about 2/3? Pause the video and write 2/3 on your own. Oh, did you pause? I'm waiting. Pause the video, write 2/3 on your own in this same manner. So if you did what I asked you to do, it should look like this. So 2 groups of 4, one group of 4, 2 groups of 4 out of 3 groups of 4. So 2/3, right? That's the same as this. 2/3 is the same as 1, 2, 3, 4, 5, 6, 7, 8 out of 12. You can do the same in the reverse direction. Suppose, so here's the original. Instead of breaking into thirds, what if I started with 6 groupings? So I have broken this into 6 equal pieces. So I have 1, 2, 3, 4, 5, 6. And I'm picking this much amount, so this would be 2 out of 6. This would be 4 out of 6. And I quickly realize, oh look, this is the same as this. So originally I had divided this into groups of 2, but I can replace it with a single group. So I'm dividing it in groups of 2, right? So if I do that, look what I have. I have 2 divided by 2, which gives me 1 group here. But 6 divided into groups of 2 gave me 3. So it's the same as before, but instead of multiplying numerator denominator by something, I am dividing numerator denominator by something. So what do you think will happen to 4/6? Remember what happened? This was 4/6. I'm replacing the 2 with 1. If I'm replacing 2 with 1, I'm replacing 4 with 2 groups then, right? And so originally we had 6. I'm dividing it into groups of 2's, but I can replace it with groups of 1, so 2 became 1. Let's take a look at another example. Here is division. The whole thing is divided into groups of 12. So if I take 4 pieces, that would be 4/12. But as you can see, this is the same size as this. So if I divide by 4, I'll end up with, take a look. So it will look like this. 4 divided by 4 and 12 divided by 4, which is the same as 1/3. This is the reason for why 4/12 is equivalent to 1/3, why 8/12 is equivalent to 2/3. Your video log question is, do this visualization exercise for the following. Listen carefully and turn it in for video log. So your video log question is, take the fraction 2/5. The fraction is 2/5. Draw a picture of 2/5 and show us how 2/5 is equivalent to the fraction 6/15. Then take the following fraction. Take the fraction 6/15 and show us how that turns into 2/5. So here's a summary of what you've seen so far. If you have a rational number a over b, you can multiply numerator denominator by the same non-zero real number, or divide numerator denominator by the same non-zero real number and keep equivalent fractions. Just on the side here, we can see that a divided by n, sometimes people write them as a over n or a parts out of n. Which represents a rational number. So here we have rational number over rational number. A rational number is said to be in lowest terms if and only if its numerator and denominator do not share any common factors. So for example, here is 15/10. This is a fraction not in lowest terms because they have a common factor of 5, but if you divide both numerator denominator by it, you end up with 3/2, which is a fraction in lowest terms. By the way, just note that 15 divided by 5 is the same as 15 times 1/5, because that's the same as multiplying by 1/5. Don't worry too much if you're not sure why division by 5 becomes multiplication by 1/5, because we will do this when we do operations of numbers. Here you have 1/3, which is a fraction in lowest terms, and you can see if you multiply numerator denominator by the same number 2, you create a fraction that is not in lowest terms. Remember, rational expressions follow similar patterns as fractions, and that's why we're interested in both at once. So you would think if you multiply top and bottom by the same algebraic expression, you would keep equivalent fractions, which is correct. And same thing happens here. Very natural to expect. If you divide numerator denominator of a rational expression by the same algebraic expression, as long as that algebraic expression is not 0, you end up with equivalent fractions. So here we have 3/x, which is a fraction in lowest terms. When you multiply top and bottom by another algebraic expression, now it's no longer a fraction in lowest terms. Here, when you divided by x, you created a fraction in lowest terms. So fractions can be looked upon as other things. For example, if you look at fraction as a decimal, one way to convert fractions to decimal is long division. But if you have nice denominators so that multiplying by powers of 2s and 5s allows you to create a power of 10 on the bottom, you'll end up with decimal numbers. Fraction in their lowest terms is terminating decimal, like you see here, if and only if the denominator factors consist only powers of 2s and 5s. And the reason for this is because we can multiply by enough 2s and 5s to make powers of 10 on the bottom. Like here you had 8 times 5. 8 is made up of 2 times 2 times 2. So 3 2s, and 5 is 1 5. So 2 more 5s completed the power of 10 for us. We'll see more in-depth discussion of this later. If your denominator does not consist of 2s and 5s, you can always do long division and change it to decimal. We'll spend more time on long division a little bit later in Module 2. So now see if you can attempt the following questions. Determine which of the fractions are equivalent to each other in the 6 questions that are here.